All right, so the next thing they're going to ask you to do is determine if the given function is linear. And if it's linear, determine the equation of a line. And how they're going to do that is they're going to give you a list of points here. So these are coordinate points, -2, -4, -1, 0, 0, 4. And one way you can go about this is to look and see if the change in x is the same. So as you see, as this is stepping up 1 each time. +1, +1, +1, +1. We call that the change in x. Change of x is 1. And if the change in y is the same as well, then we're good to go. So from -4 to 0, that's +4. And from 0 to 4, that's +4. And 4 to 8, that's +4. And 8 to 12, that's +4. So as you take a look, again, slope is the change in y over the change in x. That change in y is 4, and the change of x is 1. That is a slope of 4. Okay. If you see that the steps are the same over here and different over here, or if you find slope of 2 points and slope of other 2 points and they're not the same, then we would say this is not a linear function. Okay. So if it's a linear function, then we got to go ahead and find the equation of that line in terms of y equals mx plus b. Well, we already have m. And we can do one of two things. We can use point slope, y minus y1 equals m times the point x minus x1, and then plug in any point that you want. Here we have, again, -2, -4 that you could plug in. Or if you notice that they give you an x value of 0, that's a very special thing. And you guys probably know that is your y-intercept. That is 0, comma b. So b is given to you as 4. So you can use point slope if you want, but if you got m and you got b, you might as well get right into it. And that's y equals 4x, and b is 4. Okay, let me move on to the next example, example 4, on the next page. So sometimes they'll give you, in terms of word problems, says a strain of E. coli, known as BAO 397 Rec A, is placed in a petri dish at 30 degrees Celsius and allowed to grow. The data shown are collected in the table below and use the average rate of change to determine whether the function is linear. So again, what these represent are my x's and y's. And you can kind of see I've got coordinate points here. And I can go through and I can find the slope of these two, and then maybe the slope of these two, and compare. Another way I like to do it is just to look and see if the x's are listed up 1, up 1, up 1, up 1, up 1. My change in x is 1. Well, if my change in x is 1, then my change in y should be the same every time also. Well, from 0.09 to 0.12, that's up 0.03. But when I go from 0.12 to 0.16, that's up 0.04, and that's not the same. So my change in y is not the same every time. That means this is not a linear function. It might be a function, but it's not linear. It doesn't have consistent slope. Again, if you find the slope of these 2 points and these 2 points, you'd see they're not the same.